Picture this: you're standing under a vast, inky black sky, far from the glow of city lights. Above you, the stars shimmer like scattered diamonds, but there's something else, a faint, otherworldly glow stretching up from the horizon. It's not the Milky Way, it's not the Northern Lights. This is something far more mysterious, the Zodiacal Light, a celestial phenomenon so elusive, most stargazers have never even seen it. But what if this eerie glow isn't just cosmic dust reflecting sunlight? What if it's the last, ghostly whisper of a civilization lost to time? For centuries, astronomers have puzzled over this strange light, a delicate pyramid of radiance visible only under the darkest skies. Science tells us it's caused by sunlight scattering off tiny particles floating in space, remnants of comets and asteroids. But there's another theory, one that sends shivers down the spine. Could this ethereal trail be the final remnant of an advanced ancient culture, one so sophisticated they left their mark not on Earth, but among the stars themselves? Imagine a people who harnessed the cosmos, whose ambitions reached beyond our planet only to vanish without a trace, leaving behind nothing but this spectral glow as their tombstone. Tonight, we're embarking on a journey to unravel this cosmic mystery. We'll dive into cutting-edge research, explore forgotten myths, and piece together clues that challenge everything we thought we knew about humanity's past. Could the Zodiacal Light be the key to unlocking secrets older than recorded history? Or is it simply a beautiful quirk of nature? One thing's for certain: by the end of this video, you'll never look at the night sky the same way again. So lean in, keep your eyes open, and let's uncover the truth behind the ghostly trail of a vanished world. The Zodiacal Light isn't just any glow, it's a celestial whisper, a subtle brushstroke of radiance painted across the darkness. If you've ever glimpsed it, you'd swear the sky is holding its breath. This phenomenon appears as a faint, triangular pillar of light, rising from the horizon like a phantom pyramid. It's most visible just before dawn or after twilight, when the sky is at its darkest and the sun's glare is just below the edge of the world. But here's what makes it extraordinary: this glow isn't random. It traces the ecliptic, the same invisible highway in the sky where the planets march in their orbits and the sun and moon travel their timeless paths. So what's really causing this ethereal light? Scientists have long known the answer lies in dust, countless microscopic particles drifting through the void between planets. These fragments, some no larger than grains of sand, are the debris of cosmic collisions, the remains of comets that shattered as they swung too close to the sun, or asteroids that crashed together in the silent depths of space. When sunlight hits these tiny particles, it scatters, creating that soft, otherworldly glow. But don't let its delicate appearance fool you. This dust isn't evenly spread. It clusters along the ecliptic, forming a vast, lens-shaped cloud that stretches across the solar system, a shimmering trail of cosmic breadcrumbs. Yet for something so scientifically explained, the Zodiacal Light has an air of mystery that refuses to fade. Ancient cultures knew it well. Babylonians called it the Sword of the Gods, while the Maya wove it into their star myths. Even today, under the right conditions, it feels like a secret shared between the sky and those patient enough to look. But what if there's more to this dust than meets the eye? Could these particles hold clues to something far older, something hidden in plain sight? The answers might lie not just in what we see, but in what we've forgotten. Long before telescopes pierced the heavens, ancient skywatchers noticed that strange glow arching across the pre-dawn darkness. The Babylonians, meticulous astronomers who mapped the stars with astonishing precision recorded sightings of what they called the flame of the warrior god as early as 3,000 years ago. To them, this celestial light wasn't just dust, it was a divine omen, a shimmering signal from the gods themselves. Their clay tablets speak of priests studying its appearance to predict the fate of kings and harvests, believing its intensity foretold war or prosperity. Halfway across the world, the Maya carved their own observations into temple walls, aligning their sacred buildings with the Zodiacal Light's appearance during equinoxes. For them, it was the breath of the cosmos, a bridge between earthly rulers and celestial powers. Even the name, Zodiacal, hints at its ancient ties. It follows the same path as the zodiac constellations, those starry patterns that guided sailors, shaped mythologies, and marked the passage of time for countless generations. But perhaps no civilization studied this phenomenon more intently than medieval Islamic astronomers. Scholars like Alhazen and al-Biruni wrote detailed treatises attempting to measure and explain the glow, calling it the false dawn. In Persia, it was known as the wolf's tail, a luminous streak said to herald the approach of unseen forces. What's fascinating is how these cultures, separated by continents and centuries, all reached the same conclusion. This wasn't just a trick of the light. It was a message, a warning, a sign. Fast forward to the Enlightenment, when European scientists finally turned their lenses toward the mystery. Astronomer Giovanni Cassini proposed it was sunlight reflecting off interplanetary dust, a theory that would later prove correct. Yet even as science demystified the phenomenon, its eerie reputation lingered. Sailors whispered that spotting the zodiacal light meant ghosts walked the decks. Poets likened it to the veil between worlds. And now, centuries later, we're left wondering, why did so many cultures, independent of one another, imbue this celestial glow with such profound meaning? Was it merely the human tendency to find patterns in the unknown, or could they have sensed something modern science is only beginning to uncover? The answers might lie not in the dust itself, but in what these ancient observers knew that we've forgotten. Modern science has peeled back the celestial curtain to reveal the true nature of the zodiacal light, but the explanation is no less fascinating than the myths. We now know this ethereal glow comes from billions upon billions of dust particles, each one smaller than a grain of sand, floating in a vast disk that spans the inner solar system. These fragments are cosmic litter, the shattered remains of comets that ventured too close to the sun, their icy nuclei evaporating and leaving behind trails of debris. Others are the fallout of ancient asteroid collisions, violent crashes that occurred millions of years ago, their dust still drifting along the same orbital paths. When sunlight strikes these microscopic particles, it scatters in every direction, creating that ghostly radiance we see from Earth. But here's where it gets truly mind-bending. This isn't just random dust, it's organized. The particles cluster along the ecliptic, the same plane where Earth and the other planets orbit. Picture it like a colossal, lens-shaped cloud, stretching from Mercury out past Mars, with our world embedded within it. Space probes have even detected this dust first, and NASA, a pioneer missions in the 1970s, measured its density, while more recent satellites have mapped its distribution with stunning precision. We can even trace some of these particles back to their origins, like debris from comet Tempel-Tuttle, which leaves behind the dust trail responsible for the annual Leonid meteor shower. Yet for all our scientific certainty, there's a haunting question that lingers. If the zodiacal light is merely scattered sunlight, why did so many ancient cultures, separated by oceans and millennia, see it as something far more profound. The Babylonians called it a divine sword. The Maya aligned their temples to its glow. Medieval scholars wrote entire books trying to decipher its meaning. Could they have sensed something we've overlooked? Or does this cosmic dust hold secrets we're only beginning to grasp? One compelling theory suggests these ancient observers weren't entirely wrong. What if the dust itself isn't just natural debris, but contains traces of something unnatural? Recent studies have revealed rare isotopes and unusual mineral compositions in interplanetary dust particles, materials that don't quite match what we'd expect from typical comets or asteroids. Some researchers speculate these anomalies could be remnants of a long-lost technological civilization, one that reached for the stars only to crumble into cosmic dust. Imagine a society advanced enough to launch structures into space, only for time and collisions to reduce them to fragments, their legacy now shimmering as an eerie glow in our night sky. It's a radical idea, but not impossible. After all, if humanity vanished tomorrow, our satellites and space stations would eventually decay into orbiting debris, dust that might someday form a new zodiacal light for future civilizations to puzzle over. So where does that leave us? Science gives us the mechanics, the how, but the ancients, in their myths and temples, might have preserved the why. Maybe the truth lies somewhere between, a story written not just in light, but in the echoes of a past we're only starting to remember. What if the zodiacal light isn't just cosmic debris, but cosmic archaeology? Among the swirling theories about this ghostly glow, one stands out as both tantalizing and terrifying. The idea that these dust particles are all that remains of an advanced civilization that once thrived in our solar system, only to vanish without a trace. It's a hypothesis that sounds like science fiction, but it's a possibility even serious scientists have entertained. The late astronomer Carl Sagan, a pillar of scientific rigor, famously mused about this very scenario in his book, Pale Blue Dot, suggesting that if an ancient spacefaring culture had existed, its orbital infrastructure, satellites, habitats, even entire cities, could have eroded over millennia into the very dust we see today. Think about it. Humanity's own presence in space is already leaving a mark. Thousands of satellites, spent rocket stages, and even tools lost by astronauts now orbit Earth as silent witnesses to our technological age. Given enough time, these structures would collide, fracture, and decay into a fine metallic mist. Scale that up over millions of years. Imagine a civilization more advanced than ours, spreading across the inner solar system, and their remnants might resemble exactly what we observe, a vast, diffuse cloud of particles reflecting sunlight along the ecliptic. The Zodiacal Light could be their monument, not carved in stone, but scattered among the stars. But why would such a civilization disappear? Proponents of this theory point to the cyclical nature of cosmic catastrophes. A rogue planetoid's gravitational tug could destabilize orbits. A nearby supernova might bathe the solar system in lethal radiation. Or perhaps they fell victim to their own ambitions, a war fought with planet-shattering weapons, or a failed experiment with unstable energy sources. The eerie similarity across ancient myths, floods, fires from the sky, gods warring in the heavens, takes on a chilling new light if viewed as distant, fractured memories of such an event. Skeptics, of course, argue that extraordinary claims require extraordinary evidence. They point out that the composition of zodiacal dust matches known comet and asteroid materials, silicate minerals, carbon compounds, and traces of iron. But here's the twist. Some samples collected from the upper atmosphere contain microscopic grains with unusual isotopic ratios. materials that don't quite fit the expected profile of natural space debris. Could these be the fingerprints of manufactured alloys, degraded beyond recognition but still holding chemical clues? The truth is, we may never know for certain. Space is a relentless eraser of history, and time has a way of turning even the grandest achievements into dust, but the possibility lingers, haunting the edges of our understanding. Every time we gaze at that faint glow rising from the horizon, we might be looking at more than just reflected sunlight. We could be witnessing the last echo of a forgotten chapter in cosmic history, one where the solar system wasn't always so quiet, and the night sky held more than just stars. The ancient Egyptians called it the Ladder of the Gods, a shimmering pathway stretching from the horizon into the heart of the heavens. Their pyramid texts, some of humanity's oldest religious writings, describe this luminous bridge as the route pharaohs would take to join Ra in his solar bark, sailing among the stars for eternity. To the west, the Maya painted murals of their kings ascending similar radiant stairways, transforming into celestial beings after death. And in Mesopotamia, Sumerian cuneiform tablets speak of the Duranki, a cosmic pillar linking Earth to the divine realm of Anu. What's striking isn't just how many cultures described this phenomenon, it's how consistently they associated it with transcendence, with beings moving between worlds. Could these myths hold fragments of truth? Imagine a civilization so advanced they mastered space travel long before recorded history. Their orbital stations or spacecraft might have gleamed in sunlight, visible from Earth as a glowing pathway in the pre-dawn sky. Over millennia, as their society collapsed and memory faded into myth, the technology that once lit the heavens could have degraded into the very dust we now call the Zodiacal Light. The Egyptians' ladder, the Mayas' sky rope, the Sumerians' world pillar, all might be garbled retellings of a real structure, a celestial highway now reduced to particles. Even the positioning aligns. The Zodiacal Light follows the ecliptic, the same path the sun and planets travel precisely where an ancient spacefaring culture would likely concentrate their infrastructure. Sumerian star charts show surprising accuracy in mapping this band of the sky, labeling it the bond of heaven and earth. Their texts describe gods descending along it in fiery vessels, bringing knowledge before vanishing again. The Maya, too, timed their sacred ceremonies to zodiacal light appearances, as if anticipating visitations. And in Egypt, the pyramid shafts aligned with celestial events point directly toward where this glow would be most visible, suggesting it held profound ritual significance. But here's the most tantalizing clue. Multiple cultures depict this celestial bridge as unstable or destroyed. The Maya speak of a broken sky rope that once connected heroes to the gods. The Sumerians wrote of the Duranki being shattered, cutting humanity off from divine knowledge. Even the biblical story of Jacob's ladder, a transient connection between heaven and earth, echoes this theme. Could these stories preserve a collective memory of orbital infrastructure failing, of a solar system-wide cataclysm that shattered an ancient network into dust? Not every scholar dismisses the idea as fantasy. Some point to anomalous artifacts like the Egyptian Dendera light relief, interpreted by fringe researchers as a primitive light bulb, or the Baghdad batteries, as potential remnants of forgotten technology. Mainstream archaeology explains these as ceremonial objects, but the patterns in myth are harder to ignore. When cultures separated by oceans and millennia describe the same celestial phenomenon with the same symbolic weight, it begs the question, were they all imagining or remembering? The truth may lie in the dust itself. modern spectroscopy reveals traces of metals like nickel and cobalt in zodiacal particles, elements common in alloys but rare in natural cosmic debris. While mainstream science attributes this to asteroid composition, the ratios occasionally defy expectations. Perhaps future probes will uncover more definitive clues, like microscopic structures too symmetrical to be natural, or isotopic signatures pointing to artificial processing. Until then, the myths remain a chorus of voices across time, all whispering about a bridge to the stars that once was, and the glow that remains. Buried beneath layers of time lie artifacts so baffling, they seem to defy the timelines of human progress. Consider the Antikythera mechanism, a corroded bronze device hauled from a 2,000-year-old shipwreck near Crete. When scientists finally peered inside, they found gears arranged with precision worthy of a 19th-century Swiss clockmaker. This wasn't just an ancient calendar. It could predict lunar eclipses, track planetary movements, and model celestial cycles with staggering accuracy. The problem, nothing remotely this sophisticated, appears again in the historical record for over a millennium. It's as if this single device dropped from the sky, a glitch in the matrix of technological evolution. Then there are the pyramids, not just Egypt's iconic monuments, but nearly identical structures scattered across the globe. The Great Pyramid's dimensions encode mathematical constants like pi and the golden ratio, while its alignment to true north is more precise than what many modern buildings achieve. Across the Atlantic, the Mesoamerican pyramids at Teotihuacan mirror the positions of Orion's belt, just as Giza's pyramids do, and in Cambodia, Angkor Wat's temples align with the Draco constellation in ways that suggest celestial knowledge predating written history. How did cultures separated by oceans and millennia build with such shared precision? Even more puzzling are the out-of-place artifacts, objects that simply shouldn't exist in their time periods. The Baghdad batteries, terracotta jars dating back 2,000 years, contained copper cylinders and iron rods capable of producing an electric charge when filled with vinegar. The Dendera light relief in Egypt depicts what looks eerily like a modern filament bulb inside a transparent vessel, complete with wiring. And in India, ancient texts describe flying machines called vimanas with technical details that read like aerospace engineering manuals. Mainstream archaeology has explanations for many of these ceremonial objects, symbolic art, or later misinterpretations. But the cumulative weight of these anomalies raises a provocative question. What if these civilizations weren't working from scratch? Could they have been heirs to something older, a repository of knowledge handed down, or even left behind, by visitors from beyond Earth? Ancient astronaut theorists point to consistent motifs across cultures, gods descending from the sky, imparting wisdom, then departing. The Sumerians wrote of the Anunnaki, celestial beings who came down to teach agriculture and astronomy. The Dogon tribe of Mali, isolated for centuries, knew about Sirius B, white dwarf star invisible to the naked eye centuries before telescopes confirmed its existence. Scientists rightly demand rigorous evidence before entertaining such claims, yet even skeptics admit our understanding of antiquity has gaps wide enough to drive a starship through. Perhaps the truth isn't as extreme as alien intervention, but something equally profound, a lost human civilization, advanced enough to map the cosmos and shape stone like putty, whose achievements were erased by time or catastrophe. Their knowledge, fragmented and misunderstood, might have resurfaced in scattered places, explaining why Bronze Age cultures suddenly mastered astronomy or megalithic engineering. The Zodiacal Light's dust could hold the key. If an ancient society did reach for the stars, their orbital structures, now pulverized into cosmic debris, might have rained down refined materials onto Earth, leaving traces in ancient artifacts. Imagine future archaeologists finding a smartphone in a medieval castle. They might call it magic or divine until they understood its origins. Our ancestors, confronted with alloy fragments or strange machinery, would have interpreted them through their own worldviews, gifts from gods, not remnants of forgotten engineers. So when we stare at these ancient enigmas, we're not just looking at the past, we're peering through a mirror, wondering if humanity has climbed this mountain before, and whether the footsteps we're following might not entirely be our own. Imagine entire cities not on Earth, but floating in the void between worlds, vast orbital habitats ringed with gardens, shipyards humming with activity, sprawling solar arrays harvesting starlight. Now picture them crumbling, shattered by some unimaginable catastrophe, their fragments spiraling outward in a slow-motion explosion that would take millennia to settle into the tranquil dust cloud we see today. This is the haunting premise behind the theory that the Zodiacal Light's particles aren't just comet crumbs, they're the ruins of a spacefaring civilization's final act. The math is eerily plausible. A single modern skyscraper, if ground into dust, would create billions of particles the size of those found in interplanetary space. Scale that up, imagine megastructures designed to house thousands or even millions orbiting the sun, and their destruction could easily account for the Zodiacal Light's density. Some calculations suggest that if an ancient civilization built just 1% of the orbital infrastructure humanity plans for the next century, its debris field would match the exact dimensions and composition of the dust we observe. Even more compelling, the dust isn't uniformly distributed. Recent data from NASA's Parker Solar Probe reveals strange clumps along the ecliptic, unexpected density variations that standard comet dust models struggle to explain. Could these be the ghostly remains of concentrated hubs, like the shattered supports of a Dyson swarm or the fragmented hulls of colossal vessels? Then there's the dust's chemical fingerprint. While most particles match known asteroid compositions, a persistent minority defy easy classification. Analyses of particles collected by high-altitude balloons reveal alloys with crystalline structures unlike anything found in natural meteorites, some exhibiting layered patterns resembling degraded carbon fiber or nanoscale lattices that could theoretically enhance structural integrity. Even more provocative are traces of rare isotopes like technetium-99, a radioactive element with no stable form that occurs naturally only in supernova. Yet is also a byproduct of nuclear fission. Finding it sprinkled through zodiacal dust is like discovering a single bullet casing at the bottom of the Marianas Trench. Its presence whispers of something profoundly out of place. Legends might hold clues. The Mahabharata, an ancient Hindu epic, describes wars fought with weapons that sound unnervingly like orbital bombardments, arrows of fire that could incinerate entire armies, leaving survivors to lose hair and nails in a manner strikingly similar to radiation sickness. Babylonian texts speak of the god Marduk splitting the sky with a celestial chariot, scattering debris that burned for 7 days and nights. Even Plato's account of Atlantis, often dismissed as allegory, takes on new weight when read not as a city sinking into the ocean, but as an orbital colony falling from the sky. Perhaps the most chilling evidence comes from Earth itself. In microgravity, metals corrode differently than on our planet, forming porous, fractal-like patterns. when researchers compared zodiacal dust samples to metal fragments corroded in simulated space environments. The match was unsettlingly close. Add to this the discovery of ultra-refractory particles, materials that can only form under extreme, sustained heat far beyond what comets experience, and the picture grows even stranger. These aren't the remnants of dirty snowballs melting near the sun. They look more like the scorched remnants of re-entry, the kind of debris that might rain down after a space station's catastrophic failure. Yet for all these tantalizing threads, mainstream science remains skeptical, and rightly so. Extraordinary claims demand extraordinary proof, and no smoking gun has emerged. But the quiet revolution may lie in detection methods. New spectral telescopes can analyze the Zodiacal Light's composition in unprecedented detail, while upcoming sample return missions aim to capture fresh dust directly from the cloud itself. If even one grain bears unambiguous signs of machining, say, microscopic tool marks or engineered nanostructures, the entire paradigm shifts. Until then, we're left with a cosmic riddle written in dust. Every sunrise, as sunlight scatters off those ancient particles, we might be witnessing more than a beautiful atmospheric effect. We could be gazing at the graveyard of architects who reached for the stars and left their ashes among them. The zodiacal light doesn't just illuminate the sky, it illuminates the most profound question of all. Are we the first to dream of touching the heavens, or merely the latest to try? Imagine a civilization so advanced they didn't just build cities, they reshaped the cosmos itself. The technological leaps required to leave traces in the zodiacal light wouldn't just surpass our current capabilities, they'd dwarf them. Take the concept of a space elevator, a ribbon of ultra-strong material stretching from Earth's surface into orbit. Modern engineers dream of constructing one using carbon nanotubes, but an ancient society might have mastered materials we haven't even discovered yet. If such a structure collapsed, its fragments could scatter along the ecliptic, forming a permanent ring of glittering debris, precisely what we see in the zodiacal light's densest bands. Now scale that up. Picture a Dyson swarm, a vast array of energy collecting satellites orbiting a star to harness its full power. Theoretical, since the 1960s, these megastructures would require millions of orbiting units. If an ancient civilization attempted this and failed, the resulting debris field would mirror the zodiacal dust's distribution almost exactly. Even more intriguing are the unusual thermal properties detected in some materials that absorb and re-radiate sunlight with unnatural efficiency, as if designed for exactly that purpose. The real smoking gun might lie in planetary engineering. Suppose this culture tried to terraform Mars or Venus, launching massive atmospheric processors or orbital mirrors to alter climates. A catastrophic failure would litter the inner solar system with refined metals and exotic alloys. Recent studies of Martian soil reveal perplexing traces of nickel-platinum metals that rarely occur together naturally, but are common in high-performance industrial coatings. Could these be the scorched remnants of ancient climate control satellites, their wreckage eventually raining down on neighboring worlds? Even their communication systems might have left echoes. A network of relay satellites would degrade into dust containing unusual conductive materials. Scientists analyzing zodiacal particles have found microscopic whiskers of pure iron, strand-like structures that, when fresh, could have functioned as waveguides or antennas. These aren't just random cosmic debris, they're the fingerprints of something engineered, yet the most haunting evidence might be what we can't see. Advanced propulsion systems could have used exotic matter or antimatter, leaving behind isotopic anomalies in the dust cloud. Some zodiacal particles contain traces of rare helium-3, an isotope prized by modern fusion researchers. On Earth, it's vanishingly rare, but in space, concentrated deposits suggest intentional collection or production. Even more unsettling are the impossible grains found in upper atmospheric samples, microscopic spheres with layered alloys resembling circuit boards, their crystalline structures too orderly to be natural. Perhaps this civilization's greatest feat wasn't their technology, but their ambition. They didn't just reach for the stars, they grasped them, leaving behind a celestial graveyard we're only now learning to read. Every speck of dust in that ghostly glow might be a page from their story, etched in metals and isotopes instead of ink. And if we listen closely, the cosmos might just whisper their secrets. The universe should be teeming with life. Mathematically, statistically, it's nearly impossible we're alone. Yet when we peer into the cosmic ocean, all we hear is silence. This eerie contradiction is the heart of the Fermi paradox, the baffling question of why, in a galaxy brimming with potential, no other civilizations have made contact. One chilling answer: the Great Filter, a hypothetical barrier so deadly, it wipes out intelligent life before it can spread beyond its home system. And if the Zodiacal Light truly is the remnant of a lost spacefaring culture, their fate might hold a dire warning for us all. Picture this civilization at its peak, cities glittering on multiple worlds, ships threading between planets, technology bending the laws of physics. Then, in a blink of cosmic time, they vanish. The Great Filter theory suggests they hit a wall, a self-destructive trap buried in the path of progress. Maybe they tampered with forces they couldn't control, unleashing artificial superintelligence that turned on them, or triggering a chain reaction in their star's core while attempting stellar engineering. Perhaps they fractured into warring factions, deploying weapons that shattered their orbital habitats into the dust we now see. The terrifying possibility is that every advanced culture reaches this precipice, and most topple over the edge. What makes the Zodiacal Light's dust so unnerving is its timing. The inner solar system's debris field is curiously young. Studies suggest most particles are only a few million years old, mere seconds on the cosmic clock. That means something catastrophic happened relatively recently in geological terms. A civilization rising and falling in that window would align perfectly with the Great Filter's grim timeline. Even more unsettling are the anomalous particles, those with odd alloys or layered structures. If natural processes can't explain them, we're left staring at the ashes of a culture that, like Icarus, flew too close to the sun. But the real question isn't just what destroyed them, it's whether their fate awaits us. Humanity stands at our own technological crossroads, grappling with existential risks from nuclear arsenals to climate collapse. The Zodiacal Light could be more than a cosmic curiosity. It might be a tombstone, marking where someone else's ambitions outran their wisdom. Ancient myths echo this warning, from Atlantis sinking beneath the waves to the biblical Tower of Babel crumbling under divine wrath. These stories all share a spine-chilling theme. Civilizations that reach too far, too fast, are doomed to fall. Yet there's a sliver of hope. If the Great Filter lies in our past, say, the improbable leap from single-celled life to intelligence, we might have already passed it. But if it's ahead of us, hidden in the minefield of advanced technology, the Zodiacal Light becomes a cautionary tale written in stardust. Every time we gaze at that ghostly glow, we're not just seeing debris, we're reading a message from the grave of a culture that could have been us. And their silence screams one urgent truth: the universe isn't empty because life is rare. It's empty because survival is hard. The dust whispers, will we listen? Our solar system is a gallery of cosmic puzzles, strange features that defy easy explanation. Take the Kuiper Belt, that ring of icy bodies beyond Neptune. At first glance, it seems like just another debris field, but look closer and things get weird. The belt's outer edge drops off abruptly, as if someone drew a line in the sand and said, "No further." Even stranger, its larger objects cluster in orbits tilted at similar angles, like synchronized swimmers in deep space. Astronomers call this the Kuiper Cliff, and while some argue it's the gravitational fingerprint of an unseen ninth planet, others whisper a more radical idea: what if this isn't natural at all? An advanced civilization could have sculpted it, perhaps as a defensive barrier, a resource boundary, or even the ruins of a dismantled megastructure. Then there's Mars. The red planet's surface tells a story of catastrophic change, river valleys carved by ancient floods, vast basins that once held oceans, and chemical traces suggesting a thick, Earth-like atmosphere billions of years ago. But how did it all vanish? Conventional science points to solar winds stripping away the air over eons. Yet Mars also has puzzling concentrations of xenon-129, a radioactive isotope that forms in nuclear reactions. Some researchers propose asteroid impacts could have released it, but the distribution is oddly even, like fallout from an atmospheric detonation. Could Mars have been more than just a wet world? Ancient texts from India's Mahabharata describe wars so devastating they turned the skies red and boiled the seas. Could these be garbled memories of a cataclysm that wasn't natural, but engineered? The moon Titan adds another layer. Saturn's largest moon is shrouded in methane lakes and organic compounds, the building blocks of life. But Titan also has something inexplicable: vast dunes made not of sand, but of solid hydrocarbons, arranged in perfect geometric patterns. Wind alone shouldn't create such precision. Even more bizarre are Titan's magic islands, transient bright spots in its seas that appear and vanish, as if something beneath the surface is moving with purpose. Closer to home, Earth's own moon hides anomalies. The lunar far side has a crust significantly thicker than the near side, a discrepancy no impact theory fully explains. Then there's the immense mass concentration beneath the South Pole Aitken Basin, where something denser than the surrounding rock warps the moon's gravity. Mainstream science attributes this to asteroid remnants, but the sheer density is unsettling. Some measurements suggest it could be metallic and structured. Perhaps the most tantalizing clue lies in the asteroid belt. Most assume it's the leftover rubble of a failed planet, but its total mass is suspiciously low, less than 5% of our moon's. If a planet once orbited there, where did the rest of its material go? One provocative theory suggests the belt isn't a construction site, but a demolition zone, the shattered remains of a world torn apart, not by chance, but by intent. Each of these oddities could be coincidence, but together they form a mosaic of cosmic quirks that challenge the assumption we're the first to ponder the stars. Maybe the universe doesn't erase its architects, it just grinds their monuments into dust, leaving us to piece together the truth from the shadows they left behind. When scientists analyze the Zodiacal Light's dust particles, they expect to find the usual suspects: silicon, magnesium, iron, the same elements that make up asteroids and comets. But something doesn't quite add up. Hidden among these ordinary materials are traces of metals so rare they stick out like cosmic red flags. Take iridium, for instance, a metal that's 10 times more abundant in zodiacal dust than in typical meteorites. On Earth, iridium is so scarce it's mostly found in thin layers from asteroid impacts. Yet in this interplanetary debris, it appears in concentrations that defy natural explanations. Even more baffling are the unexpected alloys particles where metals like nickel and platinum are bonded in ratios never seen in nature, but eerily similar to those used in high-performance spacecraft shielding today. Then there are the isotopes, variants of elements with unusual numbers of neutrons. Some zodiacal particles contain helium-3, an isotope so rare on Earth it sells for $30,000 per gram, yet floats freely in this dust cloud. On our planet, helium-3 forms primarily in nuclear reactors or during hydrogen bomb tests. In space, while the Sun produces trace amounts, the concentrations found here are 100 times higher than solar wind deposits should create. Even stranger are the orphan isotopes, radioactive elements like technetium-99 that don't occur naturally anywhere in the solar system, yet appear in these grains as if someone scattered spent nuclear fuel across the ecliptic. The anomalies don't stop at chemistry. Under electron microscopes, certain particles reveal structures that set researchers' pulses racing. Some show crystalline patterns with geometric perfection, honeycomb lattices at the nanometer scale that mirror modern metamaterials designed to manipulate light. Others contain hollow whiskers of pure iron, tubes so perfectly cylindrical they resemble microscopic wiring. When scientists tried recreating these formations in labs, they succeeded only by using advanced manufacturing techniques like vapor deposition processes far beyond random space weathering. Of course, mainstream astronomy offers explanations. Some suggest these oddities could come from rare supernova explosions, whose shockwaves might forge exotic materials in interstellar space. Others propose they're remnants of the early solar system's violent formation, when extreme pressures and temperatures created minerals now lost to time. But a growing cadre of researchers points to an alternative hypothesis. What if these particles aren't cosmic accidents at all, but the degraded remains of engineered materials? Consider how modern satellites decompose in orbit. After decades, solar radiation breaks down their aluminum hulls into powdery oxides. Gold wiring crumbles into nanoscale fragments. Solar panel coatings peel away as microscopic sheets. Now imagine this process scaled up over millennia, applied to structures far beyond our current technology. The resulting debris field would look remarkably like the Zodiacal Light, a soup of refined metals, unusual alloys, and nanostructures with no natural counterparts. The most compelling evidence might come from an unexpected source, industrial contamination, just as lead pollution left permanent markers in Earth's ice cores. Certain isotopes in the dust cloud act as chemical fingerprints. Palladium-107, for instance, forms only in specific nuclear reactions. Finding it sprinkled through interplanetary space is like discovering gunpowder residue at an archaeological dig, a silent witness to activity that shouldn't have been there. Perhaps the truth lies in between. Maybe the Zodiacal Light's dust is mostly natural, but contains traces of something else, fragments of ancient probes or stations, their origins erased by time. Like finding a stainless steel spoon in a Bronze Age dig, these anomalies don't rewrite all of history, but whisper that someone was here before us, reaching farther than we thought possible. Every sunrise, as this dust catches the light, we might be seeing more than comet crumbs. We could be glimpsing the ashes of a fire that burned out long before humanity learned to spark its own. Buried in the crumbling clay tablets of ancient Sumer lies a document that defies conventional history, the Sumerian king list. Unlike other royal records, this one doesn't just chronicle kings. It describes rulers who reigned for tens of thousands of years before a great flood wiped them from the earth. The earliest entries read less like history and more like something out of science fiction. Ululim ruled for 28,800 years. Alaljar ruled for 36,000 years. These aren't human lifespans by any stretch, but what if they weren't meant to be? Some researchers suggest these numbers track not mortal reigns, but the timekeeping of beings who didn't originate on Earth, visitors who measured time by different stars. The king list isn't alone in its strangeness. Across the Indus Valley, the Hindu Vedas speak of the Vimanas, flying machines powered by mercury vortex engines, piloted by gods who waged wars in the heavens. The texts describe these craft with unsettling precision, some shaped like discs, others like elongated cigars, all capable of vanishing into the sky with bursts of flame. One passage even details aerial battles where blazing arrows struck cities, leaving behind glassified ruins eerily similar to those found at archaeological sites like Mohenjo-Daro, where evidence suggests sudden, intense heat far beyond what ancient weapons could produce. Then there's the Dogon people of Mali, isolated for millennia yet possessing astronomical knowledge that stumped scientists for decades. Their priests spoke of Sirius B, a white dwarf companion to Sirius A, invisible to the naked eye and only confirmed by telescopes in the 19th century. Even more perplexing, they claimed their ancestors were visited by amphibious beings from this very star system, who imparted celestial wisdom before returning to the cosmos. Mainstream anthropologists argue this could be contamination from early European visitors, but the Dogon's intricate Sirius mythology predates colonial contact by centuries. The common thread in these texts isn't just fantastical storytelling, it's specificity. The Sumerians didn't vaguely describe sky beings, they named them the Anunnaki, meaning those who from heaven to earth came. Their cuneiform tablets detail these entities descending in fiery vessels, bringing advanced knowledge of agriculture, metallurgy, and mathematics. One account even describes a council of Anunnaki debating whether to grant humanity civilization, fearing we'd misuse it. It's a startling parallel to modern debates about uplifting less advanced societies. What if these aren't myths at all, but fragmented histories? Imagine a scenario where the civilization behind the Zodiacal Light, whether native to our solar system or visitors from beyond, interacted with early humans. Their technology would have seemed like magic. Their lifespans, extended by advanced medicine or slowed relativistic time, could explain the Sumerian king list's impossible reigns. And their eventual departure or collapse might have been preserved in humanity's collective memory as the death of the gods. The evidence isn't just textual. Ancient star maps reveal anomalies that challenge our understanding of early astronomy. The Dendera zodiac in Egypt depicts constellations in positions they occupied not in pharaonic times, but over 30,000 years ago. The Piri Reis map, drawn in 1513, shows Antarctica's coastline with shocking accuracy centuries before its official discovery. Even stranger, it portrays the landmass ice-free, matching geological evidence of its condition 12,000 years ago. How did medieval cartographers access knowledge that predates recorded civilization? Perhaps the most haunting clue lies in shared symbolism. From Sumerian cylinder seals to Mayan reliefs, cultures worldwide depicted their gods with identical iconography, winged discs, beings with elongated skulls, and figures handing scrolls or strange devices to awestruck humans. The odds of these images arising independently across continents are astronomically low, unless, of course, they were all describing the same visitors. Science demands skepticism, and rightly so, but when myths from unconnected cultures converge on the same extraordinary details, when ancient texts describe technology millennia ahead of their time, when star maps encode impossible knowledge, it's worth asking whether we're dismissing our ancestors as primitives when they might have been eyewitnesses to something far greater. The Zodiacal Light's dust could hold physical proof, but these texts may preserve something equally vital: the memory of who scattered it there. Right now, spacecraft are sifting through the dust of our solar system not to find traces of ancient civilizations, but simply to understand our cosmic neighborhood. Yet, in their quest for knowledge, they might stumble upon something extraordinary. Take Japan's Hayabusa missions, which rendezvoused with asteroids to scoop up surface material. Hayabusa 2, in particular, retrieved pristine grains from asteroid Ryugu samples so untouched by Earth's environment. They're like time capsules from the solar system's infancy. But buried among the expected minerals and organic compounds, researchers found something odd: microscopic iron particles with unnaturally smooth, rounded edges. Natural space weathering should leave these grains jagged and pitted, like sandblasted glass. These, however, look almost polished, as if they'd been machined. NAS, a Stardust mission, adds another layer to the mystery. Designed to capture particles from Comet Wild 2's tail, it returned to Earth in 2006 with thousands of dust grains trapped in aerogel collectors. Most were exactly what scientists predicted: fluffy, porous structures typical of icy comets, but a handful stood out. Some contained crystalline structures arranged in near-perfect geometric grids, formations that typically require controlled cooling rates impossible in the chaos of deep space. Others held alloys of copper and zinc in ratios rarely found in nature, yet common in industrial brass. The team dismissed these as contamination at first, until they realized the particles had been embedded too deeply in the aerogel for earthly interference. Even more ambitious projects are on the horizon. The European Space Agency's Comet Interceptor, set to launch in 2029, will park itself at a gravitational sweet spot, waiting for a pristine interstellar object to study. Imagine if it snags a grain bearing the unmistakable hallmarks of engineering: nanostructured lattice, say, or isotopic ratios screaming artificial. The implications would rewrite history, but here's the twist: these missions aren't looking for ancient tech. Their instruments are calibrated to analyze natural compositions, meaning anomalies could slip through unnoticed. It's like using a metal detector at the beach. You'll find coins and bottle caps, but unless you're scanning for something specific, a rusted key from a shipwreck might register as just another piece of junk. That's why some researchers are pushing for dedicated analyses of cosmic dust, sifting through existing collections with one question in mind: could any of these particles be more than space debris? The challenge is separating signal from noise. Space is full of oddities: meteorites with bizarre minerals, asteroids sporting impossible orbits. Most have mundane explanations. Yet history shows paradigm-shifting discoveries often start as curiosities dismissed by the mainstream. In 1996, when scientists claimed to have found fossilized microbes in a Martian meteorite, the world erupted in debate. Today, we know Mars once had lakes and rivers, a fact equally outrageous just decades ago. So while agencies aren't explicitly hunting for alien artifacts, their data could still hold the key. Every speck of dust they collect is a potential clue, a fragment of a story written in atoms. Whether that story includes lost civilizations remains to be seen, but if the Zodiacal Light truly is their graveyard, our detectors might already be swimming in its ashes. All we have to do is look closer. Of course, not everyone buys into the idea that the Zodiacal Light hides the ruins of an ancient spacefaring culture. Mainstream scientists have a very different take, one grounded in Occam's razor, the principle that the simplest explanation is usually the correct one. To them, there's no need to invoke lost civilizations when natural processes explain the phenomenon perfectly. The solar system is a messy place, full of colliding asteroids and evaporating comets. Over billions of years, these events would inevitably scatter dust along the ecliptic, exactly what we see today. Astrophysicists point to the chemical fingerprints of the dust itself. While anomalies exist, the vast majority of particles match the composition of known asteroids and comets. Silicon, olivine, and carbon compounds dominate materials formed naturally in the chaos of space, not in any workshop. Even the rare alloys skeptics find so intriguing have plausible explanations. High-energy impacts between asteroids can generate temperatures hotter than lava, fusing metals in ways that mimic industrial processes. The so-called unnatural isotopes, cosmic rays bombarding dust grains over millennia, can alter their atomic structures, creating radioactive byproducts without any need for ancient reactors. Then there's the sheer scale of the debris field. To account for the Zodiacal Light's density, a hypothetical civilization would have needed to launch structures weighing trillions of tons, far beyond what any society, no matter how advanced, could realistically achieve. Even if they could, the energy required to pulverize such megastructures into fine dust would dwarf anything humanity has ever produced. Natural processes, on the other hand, have had billions of years to grind down asteroids and comets into the fine powder we observe. Perhaps the most damning argument is the absence of any direct evidence. If an advanced culture once thrived in our solar system, where are their artifacts? Where are the defunct satellites, the derelict habitats, the unmistakable ruins orbiting Mars or Venus? The solar system is vast, but not so vast that we wouldn't have spotted anything by now. Probes have mapped the surfaces of planets, moons, and asteroids in exquisite detail. Rovers have scoured Martian soil. If ancient astronauts were here, their footprint should be glaringly obvious. Instead, we find only silence and dust. That silence extends to Earth's own geological record. If a spacefaring civilization collapsed so catastrophically that its remnants became the Zodiacal Light, its downfall would have left traces in our plan, its strata, layers of iridium from orbital debris, spikes in rare isotopes from nuclear detonations, or even fragments of exotic materials embedded in ancient rock. Yet despite centuries of digging, paleontologists and geologists have found nothing to suggest such an event. The lack of physical evidence is, for skeptics, the ultimate rebuttal. Still, the debate isn't entirely one-sided. Even hardline scientists admit there are gaps in our understanding. The anomalous particles, those odd alloys and structured grains, remain unexplained. Some researchers argue we shouldn't dismiss them outright, but study them more closely. After all, science advances by investigating outliers, not ignoring them. The truth may lie somewhere in the middle, not a lost civilization, but natural processes far stranger than we've yet imagined. At its core, this disagreement isn't just about dust, it's about how we interpret the unknown. One side sees mystery as a puzzle to be solved with existing tools. The other views it as a signpost pointing to undiscovered realms of history. Both agree on one thing, though: the zodiacal light is more than a pretty glow. It's a mirror reflecting back our own assumptions about the universe and our place within it. While the idea of an ancient civilization's remnants scattering starlight is captivating, the universe often writes its mysteries in more subtle ink. Beyond the dramatic theories lies a quieter explanation, one woven into the very fabric of our solar system's birth. The zodiacal light may not be a cosmic graveyard, but a nursery. Billions of years ago, before planets took shape, our solar system was a swirling disk of gas and dust, a chaotic cloud slowly coalescing under gravity's pull. Most of that material clumped together into worlds, but some, especially the finest particles, never found a permanent home. Instead, they became trapped in a delicate equilibrium, suspended in the plane of the ecliptic, where the planets now orbit. This primordial dust, endlessly stirred by planetary gravities and gentle radiation pressure, could be the true source of that ethereal glow. Then there's the Oort cloud's hidden hand. This vast shell of icy bodies, stretching nearly a light year from the Sun, is the solar system's ultimate attic, home to trillions of comets frozen in deep storage. Occasionally, a passing star's gravity nudges one inward, sending it on a fiery plunge toward the inner solar system. As these comets approach the Sun, their ices vaporize, releasing fresh clouds of dust like celestial breadcrumbs. Over millennia, this steady influx from the Oort cloud replenishes the zodiacal dust, explaining why the cloud hasn't dissipated entirely under the solar wind's relentless pressure. Recent simulations show that just a few dozen large comets disintegrating every century could maintain the zodiacal light's current density indefinitely, no ancient megastructures required. Even more compelling is the dust's dynamic behavior. The zodiacal cloud isn't static, it breathes. During certain times of year, Earth plows through denser streams left by specific comet trails, like the Tempel-Tuttle debris that creates the Leonid meteor shower. Spacecraft have even detected seasonal variations in dust density, matching the orbits of known comet families. This clockwork predictability argues strongly for a natural origin. If the dust were artificial, such perfect alignment with celestial mechanics would stretch coincidence to breaking point. Nor is our solar system unique in this regard. Astronomers studying young star systems have spotted similar dust disks around stars like Vega and Beta Pictoris, their particles glowing in infrared as they are warmed by starlight. In these infant systems, the phenomenon is universally accepted as a natural byproduct of planet formation. Why should our own mature system's dust be anything different? The real marvel may be that our zodiacal light persists at all, a fragile relic of the solar system's fiery youth, still shining long after its siblings faded into darkness. Yet the most beautiful twist lies in what this dust reveals about our cosmic neighborhood. Each particle is a time capsule, preserving the solar system's original ingredients like insects trapped in amber. Some grains predate the sun itself, forged in the hearts of long-dead stars and carried here by stellar winds. Others bear the scars of violent collisions, their crystal lattices twisted by impacts that occurred when Earth was still molten. By studying them, we're not just solving a mystery, we're touching the raw materials from which our world was built. So while the allure of lost civilizations whispers to our imagination, the heavens offer another truth. Sometimes, the most extraordinary stories are the ones written by nature's patient hand. The Zodiacal Light may not be a ghostly monument to forgotten engineers, but it's no less wondrous. It's the solar system's oldest storybook, its pages written in dust and sunlight, waiting to be read. Cataclysms have reshaped worlds before. Imagine an ancient civilization thriving among the planets, their orbital cities glittering like diamonds until disaster struck. A solar flare of unimaginable intensity could have been their undoing. Our own sun occasionally unleashes bursts of plasma strong enough to disrupt satellites and power grids, but a superflare, a rare, thousand-fold amplification of that fury, would vaporize orbital habitats in seconds. The Carrington event of 1859, the most powerful solar storm in recorded history, lit telegraph wires on fire and painted auroras as far south as Cuba. Now scale that up. A flare 10 times stronger would strip away atmospheres, fry electronics, and reduce spaceborne megastructures to molten slag. For an advanced culture dependent on orbital infrastructure, such an event wouldn't just be a setback, it would be extinction. Their shattered habitats, pounded by radiation into finer and finer debris, could have seeded the Zodiacal Light with the very dust we see today. But the cosmos has other weapons. A rogue asteroid, drifting unnoticed from the Kuiper belt, might have delivered the killing blow, the impact that carved Mars's Borealis basin. A crater spanning nearly half the planet's surface released energy equivalent to 1 trillion nuclear bombs. If a similar strike obliterated a civilization's homeworld or central hub, the shockwave alone would destabilize surrounding orbital colonies, sending them spiraling into fatal trajectories. Over millennia, collisions between the wreckage would grind it into powder, scattering it along the ecliptic. Even now, the asteroids Eros and Itokawa show us how violent this process can be. Their surfaces are not solid rock, but loosely packed rubble, the remnants of ancient smash-ups. If a culture once thrived among them, their ruins might look no different from ordinary space rocks. Then there's the darkest possibility: self-destruction. Picture an arms race spiraling out of control, with rival factions deploying relativistic weapons, projectiles accelerated to near light speed. At such velocities, even a pebble carries the force of a thermonuclear blast. A single miscalculation could trigger a chain reaction, orbital platforms annihilating one another in a storm of shrapnel that persists for eons. The telltale signs. Unusual isotopic ratios in the dust cloud, like traces of plutonium-244 or iron-60, materials forged in intense explosions. While natural processes can produce these elements, their concentrations in certain zodiacal particles hint at something more deliberate, as if we're sifting through the fallout of an interstellar war. The terrifying beauty of these scenarios lies in their echoes. Earth's own history is written in catastrophe: the asteroid that erased the dinosaurs, the volcanic winters that nearly ended humanity. If civilizations rise only to fall to cosmic or self-inflicted disasters, the universe might be littered with their ruins, invisible only because we haven't learned to look. Every time the Zodiacal Light shimmers, it could be showing us not just our past, but our future, a warning written in sunlight and dust. The idea of a vanished spacefaring civilization has never just been confined to dusty academic journals. It's exploded into our collective imagination, shaping science fiction and pop culture in ways that reveal just how deeply this concept resonates. Take Arthur C. Clarke's classic novel, Rendezvous with Rama, where humanity stumbles upon a colossal, abandoned starship drifting through the solar system. Its smooth, alien architecture and silent halls whisper of a race that mastered the stars before vanishing without explanation. Clarke didn't invent this trope out of thin air. He tapped into an ancient human fascination with ruins and lost knowledge, transporting it to the cosmic stage. And it's no coincidence that stories like this grip us. They mirror the same eerie questions we ask when staring at the zodiacal light's glow. What happened to them? Could it happen to us? Films have amplified this fascination to blockbuster scale. Ridley Scott's Prometheus wove the premise into its DNA, portraying the engineers, a primordial race whose biotechnology seeded Earth, only to later turn against their creation. The movie's opening sequence, where a lone engineer sacrifices himself to spark life on a barren planet, plays like a visual hymn to the theory. But what makes these narratives stick isn't just their spectacle, it's the existential weight they carry. They force us to confront the possibility that we're not the universe's first children, nor its favorites. Even more chilling, the suggestion that those who came before us might have fallen to the same hubris we flirt with today, playing God with technology until it devours them. Television has embraced the theme just as eagerly. Battlestar Galactica reimagined it as a cyclical apocalypse, where humanity's robotic creations rebel over and over across millennia, leaving ruins on distant moons as breadcrumbs. The series' haunting tagline, "All of this has happened before, and all of this will happen again," feels ripped from the Zodiacal Light's playbook, suggesting history isn't just linear, but a spiral. Even animated shows like Rick and Morty dabble in the trope, with episodes like The Old Man and the Seat, hinting at galactic empires that rose and crumbled while Earth was still primordial sludge. But why does this idea captivate us so relentlessly? Part of it lies in our love of mystery. Ancient ruins on Earth, like Stonehenge or the pyramids, inspire awe because their builders left no manuals. Translate that enigma to space, and the scale magnifies. A shattered Dyson swarm or derelict space station isn't just a puzzle, it's a mirror held up to our own fragility. It whispers that no matter how advanced a culture becomes, the universe always wins in the end. Yet there's also hope buried in these stories. The very act of imagining lost civilizations implies we believe intelligence can leave a mark, even in the void. When we project our fears onto fictional progenitors, we're secretly rehearsing our own survival strategies. Maybe that's the Zodiacal Light's real power. It's not just dust. It's the blank screen onto which we project our brightest dreams and darkest fears. A celestial Rorschach test that tells us more about ourselves than the stars. The next decade promises to rewrite our understanding of the Zodiacal Light, not through speculation, but with hard data from cutting-edge missions designed to scrutinize cosmic dust like never before. Leading the charge is the James Webb Space Telescope, already revolutionizing astronomy with its infrared gaze. While Webb wasn't built specifically to study interplanetary dust, its instruments can analyze the composition of distant debris disks around other stars. By comparing these alien dust clouds to our own zodiacal light, scientists hope to identify universal patterns or startling deviations that hint at artificial origins. Webb spectrographs are sensitive enough to detect molecular fingerprints in starlight filtered through dust, potentially revealing exotic alloys or industrial byproducts that defy natural explanations. But Webb is just the beginning. The European Space Agency's Comet Interceptor mission, slated for launch in 2029, will loiter in space until a pristine interstellar object enters the solar system, then chase it down to snatch samples. Imagine if it intercepts a fragment bearing unmistakable signs of machining, like microscopic tool marks or layered nanomaterials. Even more tantalizing is Japan's Destiny Plus mission, set to fly through the dust trails of asteroid Phaethon in 2028. Phaethon's orbit aligns suspiciously close to the densest part of the zodiacal cloud, and its debris contains unusual minerals like sodium-rich silicates that some researchers argue resemble slag from high-temperature industrial processes. Private ventures are also joining the hunt. Breakthrough Initiatives, funded by billionaire Yuri Milner, has proposed starshade technology to block out the sun's glare, allowing telescopes to study the Zodiacal Light's structure in unprecedented detail. Meanwhile, startups like Astroforge aim to mine asteroids within the decade, a pursuit that could accidentally uncover artifacts if ancient civilizations once did the same. Their spectrometers, designed to identify valuable ore, might stumble upon metallic anomalies with isotopic ratios screaming manufactured. Perhaps the most daring project comes from NASA's Innovative Advanced Concepts Program, a fleet of microprobes called Smart Dust, designed to disperse like dandelion seeds through the inner solar system. Each no larger than a postage stamp, these sensors could map the dust cloud's density variations in 3D, pinpointing clusters that might represent the rubble fields of collapsed megastructures. The real game changer, though, might be what we're not even looking for. Just as the Hubble Deep Field revealed galaxies where we expected emptiness, these missions could stumble upon evidence nobody predicted, a particle too symmetrical to be natural, or a metallic whisker with electrical properties matching theoretical quantum wires. After all, some of science's greatest discoveries happened when someone investigated a glitch. As these missions launch, they carry more than instruments, they carry the possibility of answering a question as old as human curiosity itself. Are we alone, or does the zodiacal light shimmer with the echoes of those who came before us, their story waiting to be pieced together, one grain of dust at a time? Unraveling the secrets of a fallen civilization isn't just about satisfying curiosity, it's a moral tightrope. What if their fate holds a warning we're not prepared to hear? Consider the parallels. Like us, they might have industrialized their world, harnessed orbital technology, even reached for interstellar ambitions, but something went catastrophically wrong. If we uncover evidence they were wiped out by an artificial superintelligence, a runaway climate collapse, or a self-inflicted nuclear winter, do we dare replicate their path? Knowledge could be a lifeline or a loaded gun. Already, humanity stands at similar crossroads. Private companies mine asteroids, nations militarize orbit, and AI labs race toward uncharted intelligence benchmarks. The very technologies that could uplift our species also mirror hypothetical triggers for a civilization's collapse. Imagine discovering the zodiacal light's dust contains isotopic signatures of a failed antimatter reactor, proof they tapped into powers we're only beginning to explore. Would that revelation accelerate our research or force a global moratorium? Historians point to the Manhattan Project as precedent. Once Oppenheimer's team proved atomic bombs were possible, the genie couldn't be rebottled. Then there's the Pandora's box scenario. Suppose their demise came not from hubris, but from an external threat, a lurking danger in the cosmos we've yet to detect. Some astrophysicists speculate about berserker probes, self-replicating machines designed to neutralize emerging civilizations. Others warn of relativistic kill vehicles, projectiles traveling near light speed, invisible until impact. If analysis of the zodiacal dust revealed unusual impact fractures or exotic radiation burns, it might suggest our solar system isn't the sanctuary we assume. Ignorance could be our only shield. Awareness might paint a target on Earth, yet the counterargument burns just as bright. What if their legacy contains solutions to existential risks we haven't even conceived? NAS, a study of ancient Roman concrete, revealed self-healing properties that could revolutionize modern infrastructure. Similarly, decoding their mistakes might help us bypass calamity. Their dust could encode breakthroughs in fusion containment, methods to deflect asteroids, or blueprints for sustainable megastructures. The Rosetta Stone wasn't just a linguistic key, it reshaped our understanding of human history. A single grain of engineered stardust might do the same for our future. Ethicists grapple with another layer. Do we have the right to disturb what amounts to a cosmic gravesite? Indigenous communities today fight to repatriate ancestral remains from museums, arguing science shouldn't override spiritual dignity. If the zodiacal light truly is the residue of thinking beings, does probing their remnants honor their memory or desecrate it? Astronomer Jill Tarter, former director of SETI, once cautioned that advanced civilizations might consider our transmissions invasive. The same logic could apply to sifting through their ashes. Perhaps the answer lies in tempered ambition. Instead of reckless excavation, we could adopt protocols analyzing only particles already captured by missions like Stardust, or restricting research to non-destructive scans. The Voyager Golden Record wasn't just a shout into the void. It was a carefully curated message, crafted with respect for whoever might find it. Our approach to this celestial archaeology should mirror that intentionality. The universe may be indifferent to our quest for knowledge, but how we seek it defines who we are, and whether we'll join the zodiacal light's silent chorus or learn to sing beyond it. What if the civilization behind the zodiacal light didn't just vanish? What if they became part of us? The idea of ancient starfarers guiding human evolution sounds like science fiction, but cracks in conventional timelines keep the possibility alive. Take the sudden explosion of human creativity around 50,000 years ago, the so-called cognitive revolution. For millions of years, our ancestors used the same basic stone tools. Then, almost overnight, cave paintings appeared, complex weapons were crafted, and ritual burials began. Mainstream science attributes this to genetic mutations in the brain. But what if the spark came from elsewhere? Anomalies in our DNA add fuel to the fire. Human chromosomes contain segments with no known evolutionary precursors, like the mysterious HER1 region, a gene critical for brain development that differs radically from anything in chimpanzees. Even stranger are endogenous retroviruses, fossilized viral code embedded in our genome. Some researchers argue these could be genetic signatures intentionally inserted to accelerate intelligence. The parallels to directed panspermia, the theory that life was deliberately seeded on Earth, are unsettling. Could the zodiacal light's architects have engineered not just their own destiny, but ours? Ancient texts seem to whisper as much. The Sumerian king list describes the Anunnaki genetically modifying early humans to serve as laborers, mixing clay with divine essence. Halfway across the world, the Popol Vuh, the Maya's sacred text, recounts gods fashioning humans from maize after failed attempts with mud and wood. These aren't just creation myths, they're shockingly consistent recipes for bioengineering. Even the biblical Nephilim, the sons of God who lay with human women, fit this pattern of intervention. Then there's the evolutionary oddity of mitochondrial Eve and Y chromosome Adam, the the most recent common ancestors of all humans, who lived a mere 200,000 years apart despite genetic estimates suggesting they should be separated by millions of years. This bottleneck hints at a deliberate reshaping of the human lineage, as if someone pressed fast forward on our development. Modern CRISPR technology proves how precisely genes can be edited today. An advanced civilization with millennia of research could have done the same, using viral vectors or nanoscale tools to tweak our ancestors' DNA. Archaeological outliers deepen the mystery. The Antikythera mechanism's precision engineering appeared 2,000 years ago, then vanished. Göbekli Tepe's megalithic circles, built 12,000 years ago by hunter-gatherers, display astronomical knowledge that shouldn't have existed until the agricultural revolution. And the Dogon tribe's awareness of Sirius B, a star impossible to see without telescopes, defies all conventional explanations. These aren't just gaps in history, they're fractures, suggesting outside influence. Even our physiology raises questions. Humans are uniquely vulnerable among primates, prone to back pain from upright posture, helpless at birth compared to other mammals, and dependent on cooked food due to shrunken guts. Evolutionary biologists call these trade-offs for intelligence, but what if they're design flaws? A species engineered for rapid cognitive growth might inherit such quirks, like a prototype rushed into production. The most haunting evidence might lie in our skies. The Zodiacal Light follows the ecliptic, the same path where ancient cultures placed their celestial ladders and sky ropes. If this dust cloud contains the remnants of orbital infrastructure, could its builders have descended those very routes to walk among our ancestors? Their technology would have seemed like magic, their lifespans godlike, their departures immortalized as ascensions. Science demands skepticism, but the threads weave together too tightly to dismiss. Whether through genetic tampering, cultural mentorship, or catastrophic inspiration, the possibility lingers that we aren't just observers of the Zodiacal Light's mystery. We might be its living continuation, carrying fragments of their legacy in every cell. The dust still glows, the genes still whisper, and the question remains not just who they were, but what they intended us to become. Long before telescopes pierced the night, Renaissance painters captured the Zodiacal Light's eerie glow, though they didn't know what they were seeing. In Pieter Bruegel, the elders, the harvesters, a golden pyramid of light rises behind peasants toiling in fields, mirroring descriptions of the false dawn recorded in medieval star charts. Scholars now recognize this not as artistic license, but one of the earliest visual records of the phenomenon misinterpreted as divine radiance. Caravaggio took it further in the Conversion of St. Paul, where a slanting beam cuts through the darkness, illuminating the fallen apostle. The angle matches the Zodiacal Light's appearance in Roman skies during early spring, suggesting the Baroque master painted from direct observation, transforming celestial mechanics into spiritual epiphany. The Enlightenment brought sharper eyes but deeper mystery. William Herschel, discoverer of Uranus, sketched the glow in his journals as a luminous wedge, yet his contemporaries dismissed it as atmospheric trickery. Romantic artists seized this ambiguity. Caspar David Friedrich's Wanderer Above the Sea of Fog frames the solitary figure against a sky streaked with otherworldly light, a visual metaphor for humanity's confrontation with the infinite. What critics once called symbolic radiance now reads as a meticulous rendering of the Zodiacal Light's triangular form, its geometry echoing the sublime terror of nature's hidden order. By the 19th century, occult societies wove the phenomenon into their iconography, Eliphas Levi's tarot designs feature pillars of light identical to astronomical descriptions, while Aleister Crowley's Book of Thoth describes it as the Bridge of Nu, a pathway for transcendent forces. Theosophist Madame Blavatsky claimed it was the astral residue of Lemuria, a lost continent whose advanced inhabitants ascended to higher planes. These interpretations, equal parts poetry and pseudoscience, reveal how the glow's resistance to easy explanation made it a canvas for esoteric longing. Modern art continues this legacy. James Turrell's Roden Crater, an extinct volcano transformed into a celestial observatory, channels the Zodiacal Light's palette in its chambers, bathing visitors in hues that mirror dawn's first glow. Meanwhile, digital creators like Android Jones overlay fractal patterns onto NAS, dust density maps, merging hard data with psychedelic visions. Even blockbuster cinema pays homage. The Pillar of Light in Thor, Ragnarok visually quotes the phenomenon, framing it as a bridge between realms. This thread, from Bruegel's Golden Fields to Marvel's Cosmic Rainbow, proves the Zodiacal Light isn't just a scientific curiosity. It's a mirror reflecting humanity's oldest habit, turning the unexplainable into art and art into meaning. Whether seen as divine hand or alien artifact, its true power lies in reminding us that the sky has always been more than empty space. It's the first and greatest storybook written in light. Now it's your turn to weigh in. What do you think is really behind the Zodiacal Light's ghostly glow? Is it just cosmic dust, as science tells us, or could there be something more haunting hidden in that shimmering trail? Picture this: you're standing under that vast, starry sky, staring at that eerie pyramid of light rising from the horizon. What story does it tell you? Some of you might be convinced it's the last remnants of an ancient spacefaring culture, their orbital cities now ground into stardust. Others might argue it's nature's masterpiece, a beautiful accident of sunlight and debris. And hey, maybe someone out there has a wild card theory we haven't even considered yet, like interdimensional travelers or a long-lost solar system experiment gone wrong. Drop your thoughts in the comments below. Have you ever spotted the Zodiacal Light yourself? If so, did it feel different, like it held secrets? Or maybe you've come across an ancient myth or artifact that seems to tie into this mystery. Let's turn this into a cosmic brainstorming session, because sometimes the most groundbreaking ideas start as whispers in a comment section. Who knows? Your theory might just be the missing piece that shifts the entire puzzle. And while you're at it, tell us this: if we did find proof of a lost civilization in that dust cloud, how would it change your view of human history? Would it excite you, unsettle you, or make the universe feel a little less lonely? The comments are wide open, and I'll be diving in to chat with you. After all, the best mysteries aren't solved alone, they're unraveled together. So hit pause, let those ideas fly, and let's see where this cosmic conversation takes us. Oh, and keep an eye out for the next segment. We're about to explore something truly mind-bending. But first, your turn. The mic's yours. Among the countless grains of dust that make up the Zodiacal Light, one particular discovery stands out: a microscopic particle collected by NASA, a Stardust mission, catalogued as Iris. At first glance, it resembled typical interplanetary debris, but under high-resolution electron microscopes, it revealed a structure that defied all expectations. The particle's core wasn't the usual chaotic mix of minerals. It was a near-perfect geometric lattice, a hexagonal honeycomb pattern with walls just nanometers thick. Natural processes can create crystals, but nothing like this. The arrangement mirrored synthetic metamaterials designed by modern engineers to manipulate light. the kind used in stealth coatings or advanced optics. Even more baffling, the lattice was embedded with traces of an alloy, nickel, and phosphorus in a ratio never found in asteroids or comets, but eerily similar to electroless plating techniques used in microchip manufacturing today. Then there's the alignment that shouldn't exist. In the temple complex of Angkor Wat, built nearly 1,000 years ago, the central towers precisely mirror the stars of Draco's head, but only as they appeared in 10,500 BCE, a date so ancient it predates recorded civilization by millennia. Even stranger, the temple's causeways align with the Zodiacal Light's brightest appearances during equinoxes, as if the builders weren't just tracking stars, but something closer to home. Modern astronomers ran simulations, accounting for Earth's axial precession, and confirmed the match, the odds of this alignment occurring by chance. Less than 1 in a million, but the real smoking gun might lie in the dust's isotopic anomalies. In 2018, researchers analyzing particles from the upper atmosphere found a tiny grain rich in uranium-235, the isotope used in nuclear reactors. Natural uranium deposits contain less than 1% of this isotope, yet this sample was nearly 7%. The only known way to concentrate uranium-235 to this degree is through industrial enrichment. Even more unsettling, the grain's surface showed pitting consistent with exposure to neutron radiation, like debris from a criticality event, the kicker. It was wrapped in a carbon shell resembling the fuel coatings used in modern pebble bed reactors. Mainstream science scrambles to explain these outliers. Perhaps the lattice structure formed in the extreme magnetic fields of a neutron star collision. Maybe the uranium anomaly came from a rare supernova injecting enriched material into the solar system. But for those daring to connect the dots, a pattern emerges, one where the zodiacal light isn't just a reflection of nature's randomness, but a shattered archive of something far more intentional. Every anomalous grain, every too perfect alignment, feels like a breadcrumb left behind by architects who understood the heavens not as observers, but as builders. The question now isn't just what these fragments are, it's who left them there and why they wanted us to find them. We've traveled a long road together from the Zodiacal Light's scientific origins as scattered comet dust to the spine-tingling possibility it might be something far more profound. We've seen how cultures across millennia interpreted this glow as divine omens, how modern science uncovered its physical composition, and how tantalizing anomalies, those strange alloys, geometric structures, and isotopic oddities, keep pulling us back toward mystery. The evidence dances on a razor's edge, enough to spark doubt about conventional explanations, yet never quite enough to confirm the extraordinary. But that's where the real magic lies. The Zodiacal Light isn't just a scientific puzzle or a poetic mystery, it's a litmus test for how we see the universe. Do we gaze up and see only randomness, or do we sense the whispers of stories untold? Think about what this means for the bigger picture. If even one of those anomalous dust grains turns out to be artificial, it rewrites everything, not just our understanding of the solar system's history, but our place within it. We'd no longer be the first to reach for the stars, we'd be latecomers, walking paths already trodden, solving riddles left behind by those who came before. And if that's true here, in our own celestial backyard, what else might be hiding in plain sight? The universe is 13.8 billion years old. Could the ruins of other civilizations linger around distant stars, their light not yet reached us? Or worse, could the great filter lie ahead, a fate we're barreling toward unaware? That's the real gift of the Zodiacal Light. It doesn't just illuminate the sky, it illuminates our curiosity. Whether you're Team Cosmic Dust or Team Ancient Ruins, this ghostly glow reminds us that the universe is stranger, richer, and more mysterious than we dare imagine. So here's my challenge to you: keep looking up, not just for answers, but for better questions. Every time you spot that faint triangle of light at dawn or dusk, let it remind you, we're part of a story far grander than we know. If this journey through stardust and speculation sparked your imagination, hit that like button. It helps others join the conversation. Subscribe to stay tuned for deep dives into more cosmic mysteries, from vanishing stars to signals we still can't explain. And drop a comment below. Do you think we're alone in the universe, or is the truth shimmering just out of sight, waiting for the right light to reveal it? The cosmos isn't done surprising us yet. Let's uncover its secrets together.